Hello and welcome back. In the last video, we learned how to create a custom JTable Cell Renderer so that we can draw an image in a single cell. As a follow-up video, we are going to work on the same code to show an example of how to use the JTable to create a Tetris game. This is going to be rather a very simple and primitive game, as we are going to simulate a Tetris block moving. This is also an opportunity to demonstrate how to work with Java threads and event listeners to animate the JTable and make it more interactive. We will start by altering our code a little bit. First, we need to implement the header of our class by adding the action listener, key listener, and runnable interfaces. They are needed respectively for buttons action, keyboard input, and Java thread. By inheriting from interfaces, it is obligatory to override their respective methods or errors will occur. Add them manually or by clicking on the red exclamation point if it appears. Leave them empty for now. The next thing we need to do is representing the Tetris block on the JTable. I chose a cube. We create a static 2D array that contains both the cube rows and columns coordinates. A 2D array is an array of arrays. It is also known as nested array. We also need to create two more arrays. One to store exclusively the rows coordinates and the other to store columns coordinates. This is done by cloning from the 2D array. You choose the names as you like. We also need two more Boolean variables that we need for later. One to check if the block reached the bottom so that we make another block. The other one is to check if the game is paused. Once it is done, we go back to the private class for the custom renderer to make few changes. We need a for loop to draw our cube. With the coordinates we stored in the two cloned arrays, the cube should appear in top center of the table. If not, find what you did wrong. Now that the cube is visible, we can move to the next steps to make it move left, right, or down. We create three methods for the movement. The left and right translations will only affect the columns coordinates. Moving down will only affect rows coordinates. In each case, with a for loop, we reassign the values of the arrays by increasing them by 1 unit or decreasing them by 1 unit. We should do that inside if statement to check if the JTable boundaries are not crossed. This is some sort of basic collision detection. Besides, it may result in an out-of-range error. This means that the smallest value in columns coordinates should never be under 0 when we move left, and the highest value should not exceed the JTable's column count, which is 8 in our case. With that done, we move to override method called keyPressed so that we can call the translation methods we just created. Inside the keyPressed method, we will have three if statements where we check for keyboard inputs. If the input is A, we call method moveLeft. If input is D, we call method moveRight. If the input is S, then we call method moveDown. Make sure to bind the key listener to the JTable. The next step consists of overriding the run method. In its body, we will have a main while loop that keeps the game running for the program's lifetime. In the main while loop, we have another nested while loop where we make our block move down automatically 1 unit per half a second as long as the block did not reach the bottom yet. This while loop contains yet another nested while loop where the thread is paused if the game is paused as long as Boolean variable game paused is true. Once the first nested while loop is broken and the block reach bottom, we start over by reassigning the default rows and columns coordinates and Boolean variable bottom reached to false. Do not forget to create a thread object. Pass the keyword this as its target so that it points to the run method we just implemented. Then, start the thread in the main constructor. If not, there will be no animation. The last step is to make the pause and resume buttons work. Make sure to set focus on both buttons to false, or you will have to click on JTable to be able to move the block. We bind both buttons to the action listener, and then we head over to override the action performed method to decide what must happen if either button is clicked. If pause button is clicked, we assign the value true to our Boolean variable game paused. This variable is used in the run method of the thread. If resume button is clicked, it changes back our Boolean variable to false and calls the method we created to wake the thread and resume the game. It is important to wake up the thread this way, by using a void method with the synchronized keyword in it. Or you risk having a thread is not owner exception. If everything is done properly, you should be able to move the block left, right and down while it is automatically ascending, and when the bottom is reached, another block appears. You can also pause and resume the game. Thanks for watching and goodbye.